Okay, so today we're going to go over section 2.3, which is two-step equations. So with two-step equations, you're going to have to do more than one inverse operation. Now, typically, the way we're going to approach these is we're going to try to isolate that variable, and we're going to have to move everything that's on the same side of the equation as the variable to the other side. But sometimes the question arises, well, I have a 3 that's on the same side of my equation as my x. There's also a -7 on the same side of my equation as that variable. So which one do I move first? Well, generally speaking, you're going to do the addition or subtraction property to move numbers first. And what I always kind of say is you want to move the number that's physically the farthest away from the variable. So if you have a number that's being subtracted or added, they're a little bit farther away from the variable than the number that's being multiplied. So you're going to use your addition or subtraction property first. In this case, we're going to do the addition property since it's a -7. That's going to give us 3x equals 15. And now to finish getting my x by itself, I'm going to divide both sides by 3. And then that's going to give me my solution of 5. Now again, just as normal, you can always check by substituting in that answer of 5 into the original equation. So if you were to do that, you would simply just plug in that 5 where the x is. 3 times 5 is 15, and 15 minus 7 does indeed equal 8, so that's checked. So let's go over a couple examples. Now, for this example here, we have an x on top of a fraction. So that's going to indicate division. So again, we want to do that addition or subtraction piece first. So because I have this -3 here, I'm going to use my inverse operation and add 3 to both sides. That leaves me with x over 4 equals 8. Now, in order to get my x by itself, I need to get rid of the 4, which currently is being divided. So my inverse operation for that would be to multiply both sides. So now I'm left with x, and on the other side, 8 times 4, which is 32. Okay, number 2. Remember, the addition subtraction is what we want to do first. So we're going to subtract that 2. Then we're left with the 9y equals 27. Since 9 is being multiplied to y, the inverse operation there would be division. And when we divide, 9 divided by 9 is 1, but we don't have to put that in front of our variable. We could just leave the variable. And 27 divided by 9 is 3. Okay, so for number 3, we're going to do the addition part first here. So we're going to add the 8 to the other side, giving us 18 equals -3z. Now to get the variable by itself here, we need to divide by the -3. Make sure you don't forget about that sign. -3 divided by -3 is just 1z. 18 divided by -3 is -6. And then our final one here, again, we're trying to get this variable by itself. So we're going to add the 9 first. -17 plus 9 is going to be -8. And then we have the m over 3 on the other side. And now we're going to multiply, since we have some division going on here, the inverse operation would be to multiply both sides by 3. And we would have m equals -24. Okay, on the following page in notes, you have a whole list of practice problems. Those answers will be provided to you on Google Classroom with the answer key, but I'm not going to go through them all now just for saving time. But here is just the refresher, solving the two-step equation. First, add or subtract to move the numbers away from the variable, and then second, multiply or divide to continue moving those numbers away from the variable. All right, so example 2, let's go a little more depth with these fraction problems. So again, we want to get the fraction or the variable by itself. In this case, it's part of a fraction. We're still going to want to subtract or add first. In this case, it's subtracting a 5. So we have x over 2 equals 6. And then the inverse operation of division is multiplication. So we're going to multiply both sides by 2. And that's going to give us an answer of x equals 12. Same as always, we can always check by substituting that answer of 12 into the original equation. So we would write our original equation, putting in the 12 for the x. Oops, I forgot to put that number in there. So 12 divided by 2 would be 6. 6 plus 5 does equal 11, so that checks out. And anytime you're in doubt about your answer, try doing that and see. If you get a weird answer, it might be wrong, it might be right, but if you substitute it and check, then you'll know. Okay, again, there's some more practice problems here. Just as a reiteration here, first add, subtract, move the numbers away. Second, multiply or divide. Now, there's a couple problems on here I will do with you right now. So I'm just going to go to the last 4. So in these problems, we have fractions that have like a numerator and a denominator. So again, you're still going to use that same process. You still want to go for getting this variable by itself here. So you want to do that addition subtraction piece first. In this case, I'm going to subtract 16, which leaves me with a 14, and then I have 1/5 x on the other side. Now, if you remember from yesterday's notes, when you have an entire fraction being multiplied to your variable, you would then divide by that fraction. But how do we divide by fractions? We really just multiply by the reciprocal. So we're going to multiply here by 5, or 5/1. So we end up with x equals, and then that would be 70. So if we take a look at the next problem, again, we want to get the x by itself. We're going to subtract the 7. So now we have 2/3 x equals -8. And this is where we want to multiply by the reciprocal, because 2/3 times x, the inverse operation is divide. So 2/3 divided by 2/3 is the same thing as multiplying by 3/2, which is much easier to do when you don't have a calculator. So now we end up with just x equals, and over here you can do -8 times 3, multiply across the top, multiply across the bottom, and that would simplify to -12. However, as I always say, if you have a number on the top and a number on the bottom that reduce, like here 2 goes into 2 one time, 2 goes into 8 4, if you do that cross-canceling type of simplifying first, then you can just do -4 times 3 and get the answer that way. So it does help when you have larger numbers that you may not want to multiply in your head. Okay, this next one here, we're going to subtract the 3. So you want to add and subtract the numbers that do not have the variable attached to them first. And -6 and -3 is -9. Now we're going to multiply by the reciprocal, which in this case is 4/-3. Now, it doesn't matter which number you put the negative sign on. So here we'll end up with just x. And on this side, I again see that my 3 and my 9, I can reduce. So I can change my 3 to a 1 and my 9 to a 3. And the negatives would also cancel out as well. So it's just 3 times 4, which would give me 12. If you did it the other way, you would have -36 over -3, which would also simplify to +12. And then finally, our last one, again, you want to get rid of the number without the variable term attached to it. So that would be 18. And since my 18 is positive, I'm going to subtract it. And I'm left with 4 equals -1/4 x. So now I'm going to multiply both sides by the reciprocal, which is -4/1. Doesn't matter which number you put your negative on there. So I end up with x equals, and -4 times 4 is -16. Now the next example I want to go over with you, notice that we have 2 numbers here that have a variable attached. So we have an 11x and a 9x. Now those are called like terms because the 2 numbers both have the same variable. So examples of like terms. Okay, just to make sure we understand what like terms are. If I have a 2x and a 3x, those would be like terms because they both have the same variable. If I had a 2x and a 3x squared, those would not be like terms because one has a squared and one does not. If I have a 2x and a 3y, those are not like terms because they're two different variables. If I had 2xy and 3xy, those would be like terms because they both have the xy. If I had 2x and 3xy, those would not be like terms because one just has an x and one has an x and a y. If I had a 2x squared and a 3x squared, that would be like terms because they both have an x that's squared. So just to kind of give you an idea. So when we do this, if they're on the same side of the equation, we're simply just adding or subtracting and then sticking that variable on our answer. So 11 minus 9 is 2, and they're both x terms, so this would be 2x. Then it still equals 14, and then we would finish solving it by getting that x by itself using our inverse operations. So let's look at these examples. So for this first one here, 3x and 11x are like terms on the same side of the equation, so we can simply just do 3 plus 11 and get 14x. At this point, we have multiplication, so our inverse operation to get the x by itself would be the division, and we get x equals 2. On number 6, we have again two like terms here. 7 minus 9 would give me negative 2y. And of course, I'm dividing both sides by a negative 2, which is going to give me an answer of negative 6. On number 7, I have two like terms, again, on the same side of the equation. So I can combine them together just by doing 15 minus 12, which is 3. And now this 3w, I'm going to divide by 3 on both sides to get the w by itself, and I have w equals negative 7. All right, and then finally, this last one here, 4p and 5p again are like terms, so I can just add up the 4 and the 5, which is a 9, and I have the p there. Divide by the 9 to get the p by itself, and I have p equals 4. All right, again, there's some practice problems using the combining like terms. I will provide the answers on the Google Classroom, but I'm not going to go through every problem on the video. Again, the first step, combine the like terms that are on the same side of the equal sign, then add or subtract, finally multiply or divide. All right, so our fourth example in this lesson is using the terminology that we use with inputs and outputs, assigning them some variables, x's and y's, and creating our equation and then solving that equation. So if we remember, hopefully, inputs are the x variable and the outputs are usually the y variable. So remember, inputs are independent variable known as our domain. The outputs are dependent variables known as the range. So inputs are x's, outputs are y's. So everywhere you see an input, that's really just an x, okay? If you see output, that's really just a y. So here it's saying the output of a function is 7 more than twice the input. So how do I write that equation? Well, the output of a function that's going to be y equals 7 more than twice the input. So twice the input would be 2x, and 7 more than that would be plus 7. So the first thing that you have to do is write the equation. So that was step 1 right there. Now, step 2 is going to be solve it for when y equals 13 because it says find the input, so find the x when the output is 13, when the y is 13. So all we're going to do is substitute in. So I have my equation y equals 2x plus 7. I'm going to substitute in the 13 for the y, and now I'm going to solve it. So I'm going to solve it same way we've been doing, subtracting the 7. Dividing by the 2, we get x equals 3. So an input of 3 would produce an output of 13. So if we were doing an input-output table. All right, so let's try a couple more of these. So the output of a function is, so that's my y equals 8 less than 3 times the input. So remember, 8 less than, that means we're subtracting 8 from something. What are we subtracting it from? Negative 3 times the input, so negative 3 times x. Then the second part of the question, find the input when the output is negative 23. So that means we're putting in negative 23 for y, and then we're just going to solve for x. So negative 23 plus 8 is negative 15. And then we're going to divide both sides by negative 3, and we're going to get x equals 5. So my input of 5 would get me that output of negative 23. Okay, next one. The output of a function is 12 more than 5 times the input. So my equation here is y equals 12 more than, usually means that the plus 12 is at the end, and it's 12 more than 5 times the input, which would be 5x. So now the second part of the problem, find the input or the x when the output is negative 8, which means the 8 or the negative 8 is going in for the y, and then we're going to solve for that x by subtracting the 12. We have negative 20 equals 5x, and then we're dividing by 5 on both sides. X equals negative 4. Okay, next one. The output of a function is 7 more than negative 2 times the input. Y equals negative 2x plus 7. Find the x when the y is 29. So putting in that 29 for my output, and now I'm going to solve for my x, which is my input. Subtracting 7. 22 equals negative 2x, dividing by that negative 2, x equals negative 11. And finally, the output of a function is 4 less than 9 times the input. So that's y equals 9x minus 4. And now we want to find that x value, that input, when the output is 68. So putting in my 68 for y, and now solving for that x. So I have 72 equals 9x, divide by 9, and I get x equals 8.